It's the TED Radio Hour from NPR. I'm Manoush Zomorodi. And today on the show, small but mighty.
So, I want you to touch your face. Go on, touch it. What do you feel? Soft? Squishy? Maybe chafed? It's you, right? You're feeling you? Well, that's not quite right. You're actually feeling over 100 billion bacterial cells on your face. Those that are creating some of the aromas of body odor and stickiness. You're feeling some of the fungi that have floated down from the rafters or ceiling today. Those that set off allergies. You're likely coated with some bacterial cells that came from the fecal plumes that arose out of the toilet the last time you flushed it. Oh yeah, and there's at least 2 species of face mites that are squishing their way across your skin.
This is Ann Madden. She's a microbiologist and self-described microbe wrangler who does not seem to be bothered by what she just described.
We are an ecosystem, and so just as we expect to have lots of different creatures living in a jungle, we expect to have lots of different creatures living in our homes and on our bodies. And while that's gross, it's also pretty cool.
Anne hasn't always been passionate about the microscopic jungle that surrounds us. It certainly wasn't on her mind when she went to college.
But I had this opportunity to do an internship in the rainforest of Costa Rica. And so when I arrive in the jungle, I see these trees that are taller than cathedrals. And there are these howling monkeys that sound like dying jaguars, and these beautifully, vibrantly colored poison dart frogs that kind of sound like a baby duck everywhere. And I am in love. And as I get to help all of these different scientists study venomous snakes and poison dart frogs and plants, I realize we know nothing about our beautiful, magnificent world. And that the process of research is this puzzle, this adventure, and it never ends.
But it did end, at least for Anne. She had to go home and back to school.
And I went back to Wellesley College in Massachusetts, and everything was beige and boring, and there were no poison dart frogs, and I was as far away from the jungle as I could imagine. But then I started research in a microbiology lab, and I found out that I'd never left the jungle. There were microscopic species everywhere, just beyond the line of sight. And these species, we barely uncovered what they were. Maybe we know 1 to 10% of what these species are. And if you grow them on a Petri plate, they erupt in colors and aromas and very strange little behaviors. And many of them can do remarkable things and have been doing remarkable things, and yet they never get credit for it. And so I think that's when I fell in love with microbiology. I remember the first time I discovered and got to name a new species.
Ann Madden continues from the TED stage.
It was a fungus that lives in the nest of a paper wasp. It's white and fluffy, and I named it Mucor nidicola, meaning in Latin that it lives in the nest of another. I called up my dad, and I go, "Dad, I just discovered a new microorganism species." And he laughed, and he goes, "That's great. I hope you also discovered a cure for it." Now, my dad is my biggest fan. So in that crushing moment where he wanted to kill my new little life form, I realized that actually I'd failed him. In my years toiling away in labs and in people's backyards, investigating and cataloging the microscopic life around us, I'd never made clear my true mission to him. My goal is not to find technology to kill the new microscopic life around us. My goal is to find new technology from this life that will help save us. The diversity of life in our homes is more than a list of 100,000 new species. It is 100,000 new sources of solutions to human problems. I know it's hard to believe that anything that's so small or only has one cell can do anything powerful, but they can.
Tiny organisms with extraordinary potential. A single word that can pack a punch. A passing moment that changes everything. In a world of attention-grabbing headlines and seismic global events, we sometimes forget the little guy, the almost imperceptible but powerful forces around us. And so today on the show, small but mighty. Forget big and boisterous. We are talking about things that are minuscule or fleeting, but potent. Like microbes, which can both hurt and help us humans.
We live in a time of a horrid pandemic, so I think we're all familiar with how powerful and how devastating one microbe can be, in this case, a virus. But many microbes around us are equally powerful, but they're not devastating. So there are microbes in our dust bunnies that are the source of many of our antibiotics, and they've been saving our loved ones for as long as we've known.
One of the first jobs that Ann Madden ever had was working in research at a pharmaceutical company.
And our goal was to find new microbes, with the idea being that these new microbes could create novel antibiotics. And so that's where I really learned my microbe wrangling skills. We were using new techniques to grow microbes from soil that had never been grown before, and no one had ever explored them in the lab. And indeed, these bizarre, slow-growing, tenacious little critters were creating novel antibiotics. And though they haven't been commercialized yet, we were successful in finding them.
You knew what you were looking for then. I mean, it's not like you're like, here's a new microbe, let's see what it does. Like, what are some of the clues that you look for when you are hunting down microbes that you think might have medicinal uses?
Yeah, so part of it is the idea of guilty by association. So other microbes that live in our soil are the source of many of our antibiotics that we use today. You'll actually know if they're in the soil because they produce the smell of fresh-turned earth. And so these microbes, you grow them in the lab, and they actually look like tiny little sheep. They're adorable and fluffy. And one strategy is to then look for species of microbes that are related. The idea being, if your cousins can do it, maybe you can too.
Do you give them like bits of disease and see how they respond, or how do you test it?
Yeah, so there are different ways of assessing whether a microbe can produce novel antibiotics. And one of them is a gladiator test. So you actually put them in a Petri plate next to a microbe that causes disease. So say you've got a microbe that's MRSA, right? So it's a horrible staph infection. And you can slather it on a Petri plate and have it grow. And then you come back the next day and you look to see who grew and who died.
Oh, wow. Okay, battle to the finish.
Yeah, and so that gives you one hint. That's not the end of the story by any means, but it gives you a clue that, all right, this fluffy microbe has something that's killing off a microbe that causes disease. So maybe we can isolate that something, extract it, and maybe it can do what no other antibiotics could do before. I'm here to tell you that the next 100 years will feature these microscopic creatures solving more of our problems. And we have a lot of problems to choose from. We've got the mundane, bad-smelling clothes or bland food. And we've got the monumental, disease, pollution, war. And so this is my mission, to not just catalog the microscopic life around us, but to find out what it's uniquely well-suited to help us with. These creatures are microscopic alchemists with the ability to transform their environment with an arsenal of chemical tools. This means that they can live anywhere on this planet, and they can eat whatever food's around them. This means they can eat everything from toxic waste to plastic.
I keep thinking about what you've mentioned a couple times now, which is plastic-eating microbes. I mean, that is... We always hear about, the plastic that goes into a landfill and is going to be around for thousands and thousands of years. Is there a possibility that actually maybe that might not be true? That if we could add microbes, it would, in some fashion, break down?
Absolutely. So scientists have already found microbes that are incredibly adept at breaking down plastics, even the plastics that seem to last forever. That's really what they were designed to do. And as we think about our future, we need to think about not just the microbes that are going to break down plastic, but those that are going to help us build materials that are more sustainable. And so right now there are also microbes that generate PLA, or polylactic acid, which is the plastic-like filaments that a lot of people are using in 3D printers. And those those are made by microbes.
Are they more biodegradable?
They are. And there are groups that are now using AI and machine learning to enhance the activity of those microbe-made enzymes that tear apart plastic. And so it's going to be microbial skill sets and human ingenuity linked together to create that better future. If you were to take a sugar packet's worth of soil and you were to explore the microbe species in there, you would find more microbial species in that sugar packet's worth of soil than you would find in all of the zoos on this planet. And if you were to take just another sugar packet worth of soil, you'd find a whole nother planet's worth of species. This is the immense world that we live in at the microbial scale.
I do feel like the pandemic changed my relationship to microbes. Maybe it made me a little bit paranoid in many ways.
Yeah.
And not just the idea that there is a virus circulating among us, but potentially many scary microbes around us. How do you feel like people's relationship with microbes has been changed by COVID?
Yeah, so I think during the pandemic, particularly at the beginning, I watched as the word microbe brought chills to everyone. And I saw it in young children too, where it was a lesson that was hard learned. You know, microbes kill, they destroy, they bring with them sadness and isolation. And I think as we navigate our microbial world, it's important to also teach children and students that, again, not all microbes are evil. And so while it's important that we use hand sanitizer and things like that to limit the spread of certain microbes, we need to remember the plurality of these species and that there are microbes that we can play with in the soil and that brings with it health, not just kind of griminess or germiness of what we think of.
So when it comes to good microbes, do you worry that, just as certain species are going extinct, are certain microbes also in trouble? Have we humans caused them harm?
Oh, so what keeps me up at night sometimes is thinking about all the microbes that have gone extinct. Because we have no idea what they are. We have no idea who they were or what they did. And I don't just think about that in terms of those that are in our house that we might have accidentally killed off with some kind of bleaching agent. But I think about that in the world in terms of habitats. And as we navigate worlds where we're clear-cutting forests, we don't really know all the microbes that we've lost. And there very well might be microbes out there that are going to create the solutions to our future problems. And so one of the reasons that I know a lot of microbiologists, such as myself, love uncovering new species to science is that part of that discovery involves conservation. We are asked when we name the species to put some of those cells into a deep freeze in multiple countries. So they are sitting in biobanks where they can be revived in the future. And we don't necessarily know what any of those microbes are going to be doing right now. A lot of them sit just as specimens with Latin names that no one can pronounce. But that doesn't mean that they'll always be that way. There might be a future where they are revived and those cells will help people combat a future pandemic. Or maybe they'll help them grow furniture in space stations, or something far more mundane. But the key is that they still exist.
That's microbiologist Ann Madden. She's the founder and chief scientist at the Microbe Institute. You can see her full talk at TED.com.